Hello, I'm Arush
I'm Navin.
and today we're going to be teaching you about congruency, and then we
Congruency.
are going to be giving you some examples of some MO problems which are related to congruency. So first I'll start off by telling you how to test for some tests about how to prove that two triangles are congruent. So first, triangles are congruent if they have the same size and the same shape. If two triangles are congruent, then their corresponding angles should be equal and their corresponding sides should also be equal. So as you can see in this diagram, if ABC is congruent to PQR, angle A should be equal to angle P, angle B should be equal to angle Q, angle C should be equal to angle R, and the corresponding sides should also be equal. So the first test for congruency is SSS. So two triangles are congruent if all the three sides of one triangle are equal to the corresponding sides of the other triangle. So you can view this as if two triangles have the exact same lengths of their sides, then they must be the same triangle and the angles must also be the same. So if, as shown in the diagram, if AB equal to PQ, BC equal to QR, and AC equal to PR, then triangle ABC is congruent to triangle PQR. Next, there's the SAS test for congruency, which states that two triangles are congruent if two sides and the in-between or the included angle of one triangle are equal to two sides and the included angle of another triangle. So if AB is equal to PQ, BAC equal to QPR, and AC equal to PR, then as shown in the diagram, ABC should be congruent to triangle PQR. Now I'll pass my time to Naveen to talk about the other two tests for congruency.
Hi, so I'll be covering the remaining two congruency tests. So firstly, we have AAS, so angle side property. So two triangles are congruent if two angles and a side of one triangle are equal to two angles and a side of another triangle. So you see the diagram there. Triangle ABC is congruent to triangle PQR because angle A is equal to angle P, angle B is equal to angle Q, and side BC is equal to side QR. So there's an example given below. Next, we have a special test, which is known as the RHS test. So two triangles are congruent if the hypotenuse and one side of one right angle triangle are equal to the hypotenuse and one side of the other right angle triangle. Triangles ABC and PQR. Angle ABC and angle PQ are right angles, and a side AB is equal to side PQ and side AC is equal to side PR. So this is known as the RHS rule. Now I'll be passing the time on to Arush, who will be covering problem 1.
Okay, so problem 1 states that in the diagram, triangle ABC and triangle CDE are equilateral triangles, which means that each of the angles are 60 degrees. Given that angle EBD is equal to 62 degrees and angle AEB is equal to x degrees, we want to find the value of angle x, so the value of angle AEB. So the hint is to find a pair of congruent triangles to try to solve this question. So I'll start with the solution. So we can observe that triangle BCD is congruent to triangle ACE using SAS as BC equal to AC, CD equal to CE, and angle ACE equal to 60 degrees minus ECB equal to BCD. So this is the SAS test that I covered earlier. Thus, triangle AEB, we get that angle AEC is equal to angle BDC. Then X, it follows that x equal to 360 degrees minus angle AEC minus angle BEC, which is equal to 360 degrees minus angle BDC minus angle BEC, which is equal to angle EB plus angle ECD as shown in the diagram. Thus, x is equal to 62 degrees plus 60 degrees, which is 122 degrees. Thus, the answer for this is 122 degrees. Now, I'll be passing my time to Naveen to cover the example 2.
Hi, so I'll be covering example 2. In the following diagram, we have an isosceles triangle ABC. And in that triangle, angle A is equal to angle B and is equal to 80 degrees. And the line AM is drawn to side BC such that CM is equal to AB. So we need to find angle A and B. So if you want to solve this, hint is to construct a new triangle and use congruency tests. So if you have tried it out, this is going to be our solution. So we can first construct a new point N, and our new triangle MNC is going to be congruent to ACB by definition. Then we can draw a line NA, and the resulting situation is displayed in figure 3.2, the diagram on the left. Next, we can observe that angle ACB is equal to 20 degrees and that angle NCM is equal to CAB is equal to 80 degrees. Therefore, angle NCA is equal to 80 degrees minus 20 degrees minus 60 degrees equals to 60 degrees. Then, since triangles ACB and MNC are both isosceles and congruent, we can find that AC equals to NC because corresponding sides on congruent triangles are equal. Therefore, NCA is equilateral and CNA is equal to 60 degrees. Thus, angle ANM is equal to 60 degrees minus 20 degrees equals to 40 degrees. We also see that side NA is equal to side NM. Therefore, NMA is equal to angle NAM, which is equal to 180 minus 40 degrees over 2 equals to 70 degrees. In addition, angle AMC is equal to angle NMA plus angle NMC, which is equal to 70 degrees plus 80 degrees equal to 150 degrees. Hence, we can find out that angle AMB is equal to 180 degrees minus angle AMC, which is equal to 30 degrees. Thank you.